Okay, about how much money did he make after 12 years? 20,893. All right, and 57 cents, right? If you did it in the table, I think it just gave you 94, I believe, right? It didn't give you the change. It doesn't have enough room. All right, that's fine with me, although I think Alfaro would want his change. All right, but yes, okay. Did you put this all in the right place? Any questions on this one? No, okay. All right, so he doubled his initial investment. How long did it take him to get to 16,000? All right, I got about 9 years, right? You got to put that in y equals. On that one, you got to put x so that it changes. Don't forget to put the variable, right? And once I got it down, it was a little more than 16,000 once you got to 9 years, right? But that's about how long it took him to get to 16, okay, to double it. All right. All right, that's what, not good? It's not great. Yeah, the interest rate's got to be higher than that. Plus, if you put more in and higher interest rate, that's the way to go, right? More initial investment. Okay, 2 more. These are a little bit shorter. They're just a different type of problem. Somebody else want their name? Okay, Stephanie. Number 3, Stephanie. This time, she invests some money. Stephanie invests some money in a savings account. Okay, they're not all going to be savings accounts. We talked about this last class. They didn't like that there were so many savings accounts. In a savings account with an interest rate of 4.31%. Okay, that's a little bit more realistic. Usually it's not such a round number. Usually it's like more decimals. Okay, so it gets a little bit more out of you, really, is what it is. All right, and compounded continuously. That's our key word. That's how we know to use this formula. All right, and after 10 years, Stephanie's balance reaches $15,388. Okay, so Stephanie invested some money in a savings account, and the interest rate was 4.31%, compounded continuously. After 10 years, her balance reached $15,388. What was her original amount invested? Okay, so they're kind of asking us something different on this one. What was her original amount invested? What are we trying to find on this one? Let's just start it off with P, right? They give us A, they give us R, they give us T, but now we want to find P. Okay, so we do it a little bit different, but again, still pretty easy. The calculator is going to do the heavy lifting, okay? So this is A. Right, so same formula. A equals P e to the RT. So 15,388 equals P is what we're looking for. That's times E to the R. The rate on this one, okay, again, don't make a silly mistake. It's 0.0431. Okay, it doesn't really matter how many numbers there are. Just move the decimal place back 2. Okay, so it's 0.0431 times 10. All right, that's T. All right. Now to find P, it's P times E, all this stuff. Okay, this is all one number. Right? So it's P times that. So to solve for P, we'll just divide by this whole thing. It looks a little bit weird. But again, the calculator does all of it for you. Divide on both sides. Can't do it on just one side. E to the 0.0431 times 10. Right, on this side, it cancels out and leaves me just with P. This is what we need to type into the calculator. Okay, so I'm going to type this in just like this. 15,388 divided by E to the 0.0431 times 10. There you go. Okay, just type it in just like that, where the 0.0431 and the 10 are in the exponent. And we'll see how much did she put in originally. How much did she start off trying to save? All right, go ahead and type it in. We're about 10,000. I tried to make it 10,000 exactly, but with all the decimals, it wouldn't get perfect. So it's $10,003. But it was about $10,000. Y'all got that?